today we continue our discussion about pandas, and we'll see how we can cover. Now we are now at the half part of the book, and we see how it goes. So let's get started. So what is pandas? So basically, pandas is high performance, easy to use library for data analysis, right? So we saw Numpy, which is basically, we can say it's a library in Python that can be used for high dimensional container, right? High dimensional array and some stuff like that, right? And one thing we know is that Numpy has a lot of advantages over Python built-in array or list, which involves number one, speed, because Numpy is implemented in C, and all those kind of overhead that you need to translate the existing Python as not are not available. So Numpy is so fast. So Pandas is built on top of Numpy. So since we know that Numpy provides speed and performance and support such kind of other many operations, then Pandas is built on top of Numpy and Python. So it means that it consumes less memory and has performance which is faster than Python code. And one of the biggest advantage, difference between, while Pandas adopt many coding idioms from Numpy, the biggest difference between Pandas and Numpy is that Pandas is designed for working with tabular data or heterogeneous. Numpy, by contrast, is best suited for working with homogeneous. So we can see that Pandas can be used to work with heterogeneous data. What we mean by heterogeneous data, we mean that a data that can have combination of string, integer, different heterogeneous. But Numpy is used for homogeneous, to store the same data set of the same type. So that is one of the key advantage difference. So we already know that we can install, we already install our pandas, right? If you have Anaconda, and now here with this show version, we can see the version of our pandas. If you look at this one here, we are trying to look at the version of our pandas, but you look at it involves many other things. You can see this is the pandas 1.40, but you can see Numpy. So it means that pandas, for you to have pandas, you must have a Numpy. Can you see that? So all this stuff have been, so that's one thing we should know about the if you want to find the version of your pandas. But also we can normally import pandas series, or we can import series data frame. We'll see this one in a little bit. Let me clear these guys out. Okay. Okay, I'll run this. Okay, so let's look at this. So if you talk about pandas, the two main things that actually stand out in pandas are series and what is called data frame. This series, they are mostly used to solve almost all your data analysis problem, series and data frame. And if you look at what is series, so this is a series, all right? If we look at this, is that we can see that this is what we call index, and this is called our data. So each data has a predefined index. This is the index, this is the index. So this is series, this is series, this is series. And when we have this series put together, we can have what is called data frame. This is what it means by series and data frame in pandas. So we can see this as a series, and these are series, and these are, so we can, in a nutshell, we can say that data frame is basically in some ways concatenation of multiple series, right? So that's what is the two things that we look at in this session. Any question before we continue about pandas, data frame and series? Right. So let's look at the first one, series. And now when we finish with series, then we can see what is data frame. I would say these are the two main hosts. So let's look at the first one. So series is a one-dimensional array-like object containing sequence values. So you can see series is a one-dimensional array. So you can think of series as maybe an like a list, but with the in Python we have a list, right? And that list, it has some index that is not there, that we actually index it, right? It's not shown. So this is some like, also we have array in NumPy. So this is somehow more less like the same. So we can create a series using a keyword called here pd.series. Now you can see here we have some kind of a list, right? And now here we now create what is called a series. So when we run this, you can see that here our 476, you can see them here, but you can see that we do not actually provide this index, right? So it means this index is automatically created by pandas, right? Unlike when we have this guy, np.array, if you remember this guy, np.array, we have, for example, if I give this one here, so if I have this, then when I run this guy, you can see this is array, right? This is a NumPy array, right? This is a NumPy array, but I like to give, comparison. So you can see the difference between series and NumPy array is that in series, we have index, right? So you can see this is something easy that you can actually try to look at. And the index in the left and the value on the right. You can see the index, you can see the right, and you can see the data types is this. So by default, it store every integer in form of this, which is the same, I think, with the NumPy. Yeah, so that is it. So a default index consisting of the integers 0 to n minus 1. So here we have integer 1, 2, 3, 4. So the index will be 4 minus 1, which is 3, the last one. Can you see that? So a default index consisting of integer 0 to n minus, where n is the length of the data is created. So you can see that. And yeah, so that's what we have for that. And we can see here, this is the NumPy array, as I said. So we can see that the result of the .array attribute is usually a NumPy array, but can also contain special extension array, which will be discussed in more. So let's look at this one again. If we have our series here that we created, we can do many operations in it. So how can we just remove these values, and how can we extract all the index? So for you to do that, we have what is called the attribute called the values. When we run this guy, it will actually tell us the values. So you can see this basically returns the NumPy array, right? So the value, as you know, they are existing, they are NumPy array. So you can see this return a NumPy array. But this one will return the index. So you can see here the index, it will say it starts from 0 and stop at 4 and step of 1, right? So this is the index, just like a range we know. Why is this? Because if we look at this, we have it start from 0 and 3, right? But when we say stop, here it says stop is 4, because you remember the last one is not included, right? So 0 is starting, stop is 4. It means this is not inclusive, and the step is 1 because we step from 0, 1, 2, 3. Can you see that? So this is 0, 1, 2, 3, right? So this is what index will tell you. So these are some of the attributes provided by series. But you can also actually, if you have your index, you can suppress the index, right? So you can provide the index. So here we have 4 digit, 1, 2, 3, 4. You can say, okay, this is the index. Don't use the default, right? So if you say this is the index, then you can have the index specified, right? So you can have your index, don't use the default. One thing we should know is that pd.series here, you can see it start with capital, right? Not series here. If we use this, you can see we will have an error. So one thing we should know that this is capital, right? So does anybody knows why we use capital here? Because if you look at them here, if we want to define an array, a numpy array, we use np dot, right, np dot array like this, and we provide the arrays we have like this, right? This is how we define an array in numpy, right? So you can see here that the array here, the A is not that capital, right? It's small letter. But if you look at this one here, we have the series, yeah. So that's different. So anyway, you know already this, right? So let's move on. So this is the index. We already show what index shows. Index, which basically shows you the index of your series, right? So compare with numpy array, you can use levels at the index. So we know in numpy array, we can basically use the indexing. So let me show this. If we have a numpy array like this, we can say np dot array, and we can have this guy. We can have two. Okay, so we have this as our array, right? Now, who can tell me if we want to index the last number? How can we index the last number now in NumPy? So we have NP. How can we index the last number? If I want to index 5, how can I do that?
So we have two ways.
Okay.
We can either use -1,
okay,
or we use 2.
Okay, yeah, we use the index 2, right? Because, you know, yeah, right. So you can see we index it, or we can use -1 because it's we start from the last, right? So yeah, so this is NumPy. But in Pandas, since we have our object 2 here, that has it is indexed specifically designed or explicitly available, then we can use this index. So when I said this object A, this will give me this number, right? So we can see they are more or less similar. Don't forget we said Pandas was built on top of NumPy. At the back end, Panda, because there are many other operations that can use very useful in Pandas that are not in NumPy. And if you are doing data analysis in Python, Pandas, you must become master of Pandas. If you are doing data analysis in Python, then Pandas is the way to go, and you must master it. So we will see a lot of project that we practice. So we can see also here, you can assign, basically change the value in D. So I have a D position here. We can see is 4. We can assign a number to replace that one. So we can see here, basically we replace the D with a new value, which is 6, right? So yeah, so that's it. And here we have another one here. So basically this one, if we go back to our array, so here assume I want to, how can I index 2 and 4? 2 and 4, how can I index 2 and 4? How can I index 2 and 4 at the same time?
2 or 22. Is it 2 or 22?
Okay, how can I say like this, array, then open bracket, I said what?
0,
0,
1.
comma 1,
No.
like this? No,
No.
like
We use
this,
columns.
1.
like this.
Start from 0. You start.
What? How can we do that? I want to index this and this, the one and this one only. How can we do in NumPy?
You can put column 2. I think it's okay.
Okay, we say column 2.
It's okay.
No, it is supposed to be
Column.
column 1 since it will
Column.
start from 0 and 1.
Column 1?
No, column 2. Column 2, not 1.
Okay, let's see.
Only
see.
column, no 0. Column 2.
Like this?
Yes. Without 0.
Right. So it means we are saying start from 0 and 2 is not included, right? So it will start from 1. So you can see how we do in NumPy. Now, so it's the same thing, and also it's the same thing in series. So you can see this one. That's why they said in the previous chapter that understanding of NumPy will give you understanding of Pandas. So you can see here this one. When we say give us CAD, it means it will give us CDA, all this value. So this is, yeah, so this is how we subset this. So here is interpreted as a list of indices, even though it contains string instead of what? Integers. So you can see here it contains integers, string of integers, unlike this one here in NumPy, where we basically have use numbers. You can see in NumPy, we use numbers to basically index, right? So that's it. Compare with NumPy array, you can use labels in the index when selecting single value or set of values. Okay. All right. So the same thing, some of the operation we saw in NumPy also works in Pandas. So for example, we have our, what do you call it? Series, which is this guy. And when we run this, let us remind us what this guy means. Okay, so we can see that, oh, I don't know why this is taking so much time. Let me close my, I don't know what is taking my, okay, let me see something. Activity monitor. Okay. Google. Excuse me, let me turn off some stuff. Taking my memory. Okay, this guy. Okay, so we can see this is our this, and now we can say, okay, what is basically the we can use this like some of mathematical operation. We can say this object greater than 0. This means that any value that's greater than 0 will be returned, right? Let's see what will happen. You can see because everything here is greater than 0. It's only -5 that is less than 0. It's not returned, right? We can also do multiplication. So when we do multiplication, basically everything will be multiplied, right? But you can see the multiplication does not actually multiply the index, right? So the index is just telling you, just keeping the location, but it is only the object that will be multiplied. Here also you can see, yeah. So that's this about this. And when we look at this as well, yeah, so this is also, you can see the expression exponential, right, of this object. We can see, so what this is telling us that when we do operations, any mathematical operation can be used on top of your object and it can be reflected. Another way to think about series is a pig's length ordered dictionary, right? As it is a mapping of index value to the data value. So another way to think of series is a fixed length ordered dictionary, as it is mapping. So we know in a dictionary, we have, we basically have, what do you call it? We have the value and also the index, right? So more or less like that also, in the sense that this is the value, this is the key, this is the value, this is the key, this is the value, this is the key. So you can have the mental model for thinking about series, about some kind of a key value. Yeah, it's a fixed length, right? Ordered dictionary, as it is a mapping of index value. So we can also do this. We said B in this. We know in dictionary, when we say something in this, it compare with the basically the key, right? So here also, when we say B in object, it means it is comparing whether this B is a C is an index in our series. So you remember that's also works in dictionary. So also here there's something that's what actually happens. So this is what we call a series in Pandas. Any question before we move on? Any question? All right, so we now have seen how to work with series, and we saw how to create a series. The next thing we see is how we can create a series from different ways. So just to recap, this is called a series where we have a data and we have the indexing of the data. This is a series, this is a serial, right? And one thing with series is that it can contain different kind of data types. So we can see here, the data is list, the data is string, the data is what here is digit. And now here we have a tuple, we have dictionary. So everything series can contain. So that's one key difference between, as we said, Pandas and Numpy. Pandas contain heterogeneous data. What we mean by heterogeneous? Different kind of data, while Numpy contains homogeneous, similar data with some characteristics. So let's move on a bit and see more about how we can create Pandas. Any question? Okay, so creating a series from dictionary. So here you can see I made mention that we can think of about series, about the mental model, about somehow kind of dictionary mapping of key, right? So we can create basically a series from dictionary. So here I have a dictionary, and now I can use this pd.series and now provide the dictionary, and this would basically create as a series for you. So you can see we have a series here, right? So we have a series. So when you only pass in a dictionary, the key in the resulting series would respect the order of the key according to the dictionary key method, which depend on the insertion order. So we can see here, this guy is the first one. This is the Texas. This is the Oregon. This is the Utah, right? So what they are saying is that the key value here will respect the dictionary what we have, but you can actually override this the key. So what this means is that, let's assume that I have because if you look at this one, I have how many data point? I have 1, 2, 3, 4, right? Now let me create a list which with another dictionary, with another state, California, Ohio, in this order, because if you look at this one here, I have Ohio, Texas, Ohio, kaza. But okay, I say maybe this is not the correct state, right? I need to change it. So for you to change it, just create a list. We have the 4 because I have 4, right? And now I say PD the series. I put the my dictionary, and now you can have an argument index. Then you provide yours. So this will actually override the existing one and now create a new series with the supplied stuff. So you can see we have this. But if you look at this one, you should know that in the new one, we actually don't have California, right? We don't have California. We have this guy and this guy, and we have 4 states, right? But now we say, okay, use index 4, right? So if California, since it does not exist, they will put none, and none means not available. Oh yeah, null value, right? Does not exist. There is no available value for that. So 3 values found in exit data were placed in appropriate location. You can see that. But since no value for California was found, it appears as not a number. So you can see this is not, which is considered in Pandas as mark of missing or NA value. So in Pandas, NaN is means missing value or not a number. So maybe you actually you did not provide the correct value for California. And since eta was included in data, it has excluded from the resulting object. So, and also you can see here, we don't have Utah. So it's, but originally in the data, we have Utah, but in the new list, because I provided a new index, which Utah was not there, then it means it will not be available in the next one. Any question? Right. So you can do many operations on your object. One thing you can do is that we have what is called pd.null. It's null. So this is null is trying to show you which actually value is null object, not a number. So when we run this guy, it will actually tell us what is not a number, and we can see that. So if you look at this, you can see that California is not a number, it's a true, right? So it's null. This is not a null, it's false, but this is true because it's null, right? So this is one method to actually check in your data, what you see in the next session when you start doing data analysis on what is null value. So you need to try to check if you are going to do machine learning and you are be given data, and you have tons of data. So before you go that, one step is to look at what is the missing value in those columns. Now, this kind of way is show you the missing value, and you can filter where we have false, right? Where we have it's null, where it shows you it's true, then you can filter those columns. Because if you have a missing value, then they could create a problem in your analysis. So this is one way, and we'll see them in the next chapter, how we can do such analysis with them. And this one, not a null, it's also another method that shows this is not a null, but this is a null. Yeah, so yeah, this because it's null, it said it's false. So this is another method. This is also another method that actually basically what it does is that it's NA. So it's more or less like this first one is null, and it's NA. They are more or less the same. It's null. Let's work toward this guy and run this guy as well and see what will happen. So you can see, oh, okay, let me comment this guy and run it again. So we can see this guy, actually they are the same thing. So it's null, it tells us the truth. It's NA, this is true. So this means that they are basically trying to tell us the same thing. And we can see they are all Boolean stuff. Any question? So a useful serious feature for many applications is to automatically align by index level in arithmetic operations. So let's look at one thing here. We have our object 3 here, and we have another object here. Okay, so we have this object here. This guy. This guy. Okay, so here you can see we have these guys and these guys, right? Now, if you want to do data analysis, for example, this is a list of people or states with their income in a particular year, and you want to add the income for the 2 years. So because you have Texas here, you have Ohio, you have, so you want to add the result of Texas for the result of Texas here. You want to add the result of Oregon here and Oregon here. How can you do that? You can basically do addition of this stuff. How can we do addition? How can we specify, tell the Numpy Pandas that please check for where is Texas and check where is Texas in this one and add this one and this one. We are not doing any for loop or whatsoever to try to detect what is the index whatsoever, but Pandas will automatically at the background. You don't know, just add them. Pandas will automatically match the corresponding indexes. So let's look at what will happen. when we say this guy, we say, okay, add this and this. So we'll see what will happen. So you can see here, Texas, we have 7100, right? So we have 7100 in Texas, and also here 7100 in Texas, right? Right. So when we add the Texas, we have 14200, right? So you can see Pandas will know automatically how to look for each of the index. They are the same and add them. Remember, if it is pure Python that you want to add this, you need to implement some kind of for loop, trying to check is this equal to this. If this is equal to this, then merge, add this one, right? So Pandas, one of the great thing is that it will actually automate this. You don't need to do that. Yeah, any question? Any question? Right. So if there's no question, let's get going. Did no question?
No question, Doctor. No question.
Yalle ka abin nan yau internet ɗinka baya shi da matsala.
Yanzu lalle kam ga kuma rashin mahayaniya. Sometimes ka san.
Okay. Right. Okay. So let's continue. So data alignment feature will be addressed more in detail. So in small sections, we will see this issue is called data alignment. But we can think of this data alignment and what we call join operation. One thing we should know here is that if you look at California here, it's not a number. And you can see here, we don't have California, right? Now you can see as the result, we have California, not a number, because you cannot add it. And also you can see here, we don't have Utah, right? And in the other one as well, we don't have, we have Utah. Here we have California. Okay, here we have Utah, but the other one we don't have. So therefore Utah is also, because there is nothing to add. So all this one will be discussed in the next chapter. It's discussed thoroughly. Right. So the series and has what you call names attribute. So let me show you something like this. So if you look at this one here, this is a series, right? California, this is a series, but this series does not have a name. How do you call the name of this series? It doesn't have a name, right? So series has an attribute called name that you can refer to it and use it in future. So let's look at this. So here we can say object that name population. So here, because this series is about the population of people, we can name this series. So this, using this argument, object that name called population, we are now naming. So let's look at the difference between them. So you can see here we have an attribute called name population, right? Unlike previously, you can only have the data type, right? So you can see here, when you are working with the data, a lot of data, sometimes you need to name your series or whatever. So when you are doing, somebody send you a stuff, you just try to look at it. Okay, you can see, okay, this is a series for population. So you should know what it is. So it is good idea to name your object. We also have what is called, you can see here, object that index that name. Now when we run this guy, we can see right. So you can see here, we said object index dot name. You can see now the index, these are the index, right? California, Ohio, Oregon is now named. Can you see that? Unlike before, can you see that it is only now when you add so unlike before, you can see here the series does not have a name, the index does not have a name, right? Now we know that we can now name our series. We can now name the index. Can you see that? So this is very useful in analysis. Yeah, as we see in the subsequent chapter. So Yeah, a series index can be altered in place as well. So let's look at this. So we already know what we mean by in place, right? When we say operation in place, it means we want to alter something. You don't need to use assignment equal to operation. So what they are saying is that a series operation can be altered in place. So here, when we see this, that we have a series here, we have 47 minus 53 as the value, and these are the index, right? Now we can say, okay, this guy that index, we assign new values. This means that now the index will now change from the 0, 1, 2. We now have a new index. That's about series. Any question before we move on? Yeah, so to recap, we said in Numpy and Pandas, I mean, the workhorse for Pandas are two things. Number one, series, and the number two, data frame. We now have seen what series is, what we can use with series. Series is basically a container for objects of different type, heterogeneous, and they have what we call index, and we can assert them. So we'll see how they are useful in the subsequent section when we go to the data analysis. For today, here we are given the basis of how we construct them and how we do that. So let's move on to the data frame. Now, a data frame basically it's a rectangular table of data. This is the kind of data we will always see when we come to machine learning. It is a rectangular table of data and contains an ordered name collections of columns, each of which can be of different times. So you can see here, this is a column, this is a column, this is a column. Now, as it already shows, when we put together a series, it gives us a data frame. The data frame has both rows and column, and it can be thought of as dictionary of series sharing the same index. So we can see here, for example, I have a dictionary here, name. Can you see that? I have age, I have department, right? So we can see here, this is the name, this is the age, this is the department, because what this is telling us, this is because this is a dictionary, it's telling us for Jim, this is his age, and this is the department cells. For Duet, this is his age, this is a sales department. For Angela, she is 27 and she's in accounting, right? So we can actually put this to look like data frame. So this, you can see, it looks in the format of data frame. So yeah, so how can we create data frame now? That's the question. So we can create a data frame in many ways, but let's look at one way to create the data frame from dictionary. So let's look at this is a dictionary. We already know this is a dictionary, right? So since this is a dictionary, we can use what is called pd.dataframe. So look at it, when we use the dictionary, we use pd.series to create a dictionary. So here we can create a data frame. So we can call frame. Oh, okay, I already have one. I can delete this guy, and now I can run my frame here. And we can see that this dictionary representation has now been changed to actually data frame looks. All right. What is still taking much time? Right. So you can see now we actually have this stuff. So while data frame is basically two-dimensional, you can use it to represent higher dimensional data in tabular format using. So we can see here, data frame is in two-dimensional, right? So we have dimension here, we have another dimension here, right? So this is two-dimensional data frame, but data frame can actually be used to represent higher dimensional, and we will see that. Now, we now move on from series to data frame. So data frame can contain multiple series. When you put series together, you can create data frame. And as I said, when you move to machine learning, this is the data structure you will be seeing. So data frame are very, very used in machine learning. Every machine learning is the data, your data. We have a function called head that actually, which is basically a pandas function that shows you the topmost values in your frame, in your data frame. So here we use this, and we can see here basically that the data frame you have here, that we have the index 0, 1, 2, 3, 4, right? But if you look at this one here, we only have a dictionary. We don't have the frame, right? This is this one, this is this is this. Now it turns out that the frame here, while your key becomes the column header, right? Your key, can you see that? Your key pop become the column, right? The keys, they are this one. While the entries, OYO, can you see that? Becomes the values, right? Can you see the value? Here is the key and the values are here. Pop the key and the value. So this is how the dictionary is represented as a data frame. Now let's move on. While a dictionary has already mentioned this, and this is also a method that can be used, that if you specify a sequence of columns, the data frame column will be arranged in that order. So data frame basically respect, as we said, the dictionary stuff. So when it comes, you can see that we have state is first, year, pop, right? So it will put them in this order, state, year, pop. But if you don't want that, you want to actually override this stuff, then you can provide your argument that you want. So you can say you have a column, state, year, state, and now when we run this guy, this will basically give us the same data frame, but actually it changes its own column structure. But you can see when you say year, this year, you can see it will all the column. Can you see that? States, you can see all the column. Pop, you can see all the column, right? So this is one way to manipulate your column. If you pass a column that is not contained in a dict, it will appear missing value. So when you pass something that's not contained, it will appear as missing value. This is another one here. You can see I have a data and I have my data and I have a column year, right? State, pop, date, right? You can see previously I have only 3 columns, right? But now I add another one, and now I add another index. So you can see instead of using default index, which is basically 0, 1, 2, 3, 4, I'm providing my index 1, 2, 3, 4, 5, 6, and now this is it. So it means data frame, this guy data frame has parameter column, has argument called index. The column is a parameter that can be used to show the column arrangement, and the index is a parameter or argument that can be used to show the index argument instead of using the default value. And here the column that we don't know, date, is now not a number, which we saw. Yeah. Any question before we continue? Okay. Now, if we want to see, for example, we have 50 columns, you see, like when you watch your data, you will not be able to see 50 columns up to here. If you have 1,000 columns, they will not be laid out here. So you can use one attribute called columns. It will basically show you the column in the data, because here we have 2 columns which are 4. That is why we can see it here and understand how many columns the data frame has. But if you have very large, so you can see here, it tells us how many columns we have. A column in a data array can be retrieved a series. So more or less like series where we retrieve with index. So also in data frame, you can use the index here. So we have a state here. If you look at this one here, I have a state, right? I have here. So if I want this column state, right? So if I want this column, what I need to do is basically to provide this frame and state. And now this guy will give me the column I needed. Okay. Right. So you can see it basically give me the column, but you can see we have state. It now gives me something that looks like a series, right? So we have state, we have the index, and we have the column of that state. So if you look at this one here, we have the state. This is it comes with the index, right? And we can see here the name of the state. All right. So yeah, so attribute like access, this cannot be so what you should know is this. We have different way to actually use attributes. So for example, if we have this, let me show us here. So here we have our data frame, which is called frame 2. Now if I use this dot, it will basically in VS Code try to show you many kind of attribute or function that you can use. But we have in our data frame, we have year, we have states. So if you type this only one here, you can type state, ST. When you type state, it will try to show you yeah, can you see state? So what is happening here is that all the attribute will be, yeah, so here you can see we are taking state. Can you see that? So we can use this tab like to how can we now we see how we can actually subset a column. So to recap is that given a data frame like this, if you want to take this column or this column, what you need to do is basically to use this, right? To use this. But what if I want to have 2 columns, not only 1? So it means yeah, so this guy is suggesting to use this. So when we run this guy, so this gives us an error. Why this gives us an error? So you see previously, if it is an array, what we basically use is to use something like this, right? In an array to subset a pandas and a numpy, right? Now, if we want to have more than one item to select from the pandas, how can we do that? Now we can see, now we select only one column, right? And the column we select here is this. Now, if we want to select this guy and this guy, how can we do that? Or we want to select from here to here, from one non-column down to one non-column down. How can we do that? We want to select from this column to this column, not even two, from this to this. Falalu, how can we do that? Anyone with the idea how we can do that? So can we, now when we have this, what about this? Can we do that this? Is it correct? Can we do this? So let's run this and see what will happen. So basically, when you try to subset this, when we use in NumPy will not actually the same way it uses, right? We'll see now how
we have to use LOC.
Yes, exactly. So we have what we call, we will see it in the future, how we can access this. So we have what we call ilog and we have what we call log. We'll see it in a bit. I'm just trying to introduce it to see how we can use this feature. But we can see this in more detail just in a bit now. Here we access only a single column, but we see how we can do that. But also now what I want to introduce is how can we subset a row? How can we subset a row? Now we saw that for us to subset a column, we just provide the name of the column, right? This is the column. Now, for us to subset a row, can we just also provide this a row? Let's look at it. So for us to do that, and also if you want to select a column, you can also just use the name of the column like this without using this format. Using this. Can you see this like this one? Here we use this form of subsetting, but you can also use this format. It will give you the same thing. So two different approaches to select a column from Pandas data frame. So for us to actually retrieve a row, here we can use this, what is called LOC. So who can tell us what the meaning of this, full meaning of this? Who can tell us? Okay, so when we run this, the same thing we can see here. For assessing a column, what we did basically was just to give the name of the column we have like this. Can you see that? Name of the column, just like this. We just provide the name of the column. But in assessing the row, rather than doing that, we need to use some form of I don't know why this is taking. Yes. Yeah. So you can see here, we want to access the row 3. Now we use this LOC, and now we say, okay, use row 3, which is basically this. Where is the data? Yeah, row 3, you can see this is this 2, 0, this guy and this guy. So it subset this one. All right. More or less, we can also modify the column. We can modify a column by its content, but here you can see we said, okay, the date. So let's look at what is frame 2 now. Again, I remember ourselves. Frame 2. And now we can see this is the frame 2. Right. So we can see here we have date here, which is none, right? Now, who can tell us how can we replace the date column with some values? How can we
Doctor, can we take max?
Can we take what?
Max.
Max?
Oh, max, but the one we are using in NumPy. Oh, it's not possible.
No. I want to replace the values here. The values here
instead of none.
Value.
I said instead of none, we want to replace it with values.
Maybe 3 with 3.
Okay.
I think we need to just select the column name, then we assign the value to it.
You say what?
We select the column depth, then we directly assign the value to it. We use equal sign and then assign the value.
Okay, so here, something like this, we select the column name and we assign a value, right? Exactly. So you can see here, we actually put the values here, this, right? Because this is a single value, it means it will propagate and replace all other values here. But we can also say, okay, now since the date here, we have 6, 1, 2, 3, 4, 5, 6. Now, if we pass a 6 number, it means each one will be assigned to one value. So let's look at this one, because here we assign a single number, so we can have this. So you can see, because arrange, you remember, it's NumPy 6, then any number. Because we say arrange 6, this means that it will start from 0, 1, 2, 3, 4, 5, 6, right? So that's where we have this. But you cannot actually assign. So here you can see when we assign a single number, it propagates like this. But you can only assign numbers that equals to the number of index you have. We have 6 here, we can assign 6. But when I assign 5 here, this will give me an error. What this means is that if I have this, I give 5 numbers. So it means while I have 6 rows, I give 5. So this will give me an error. But when you give a single number, then the single number will be replicated 6 times. 1, 2, 3, 4, 5, 6 times. So that's basically how this is done. Yeah. So let me show us how we can do the selection, because I think it's not explained as I said. Let's show us how we can do selection of multiple columns in the Classifier. So here you can see I have frame 2. This is the column I have. Now I want to select maybe column state and for pop, for example. Now for me to do that, we can basically use this, right? We said this guy, and we say, okay, this guy, right? But we need to provide what we are indexing in the form of maybe a list. So we can say, okay, what we want is give us the states and give us the pop. All right. So we need to pass this here inside it. So let's look at what will happen. So you can see here, we basically pick this column and this column, right? So this is one way. There are a lot of ways. I don't want to introduce it here. I think in the next they discuss it. We basically also, this is one way. Another way is this. We can use this guy. We can say, okay, this guy from 2, we use what is called iLock, which basically iLock, and basically we say, okay, give us all row, and we maybe start from 0 to 2, or from 1 to 3, 0, this is 0, 1, 2, 3, okay, 3 maybe. So let's try this one. Yeah, you can see also this one give me this and this, right? So there are many ways to actually base. So ilog is used to select columns in your data frame, rather than the previous one I showed you, which is called log or LOC here that we have seen here. Where is it? Can you see this one? Log to subset the row, right? Here we select the row. So just think of it. ilog is for column, log is for row. Any question before we continue? Well, look, common thing that as indexing column. Okay. So yeah, so that's how we can index columns. Anyone with question before we move on? Okay. Well, okay, what do we have more time? Okay, we have 40 minutes. Okay. Right. Any question? Okay, so let's continue. So now we have seen how we can access column and how we can access rows in Pandas data frame. Now, if you assign a series, to a column in a data frame, what will happen? The question here I'm trying to answer here is this. Here I assign 6 numbers to a date and it replaces this. Here I assign a single number to a column and it propagates this. Now, what about if we assign a series? So here I create a series, pd.series. This is a series, 1, 2, 3, and it has its index, right? 2, 4, 5. Now I say, okay, this series is now assigned to date, which is that column. So now what will happen is that only those available states, so we can see here 2, right, will now be assigned the value minus 1.2. 4 will be, so only all other ones that are not present in our index, in our series that we pass, will have a none, which is not a number. So this is something we should know. And assigning a column that does not exist will create a new column. So what we mean here is that we are creating a new column called, so let me say this guy, let me represent it in a different way. Okay, so let me say A is equals to, so here you can see here, I have what is called A. And now let me show this guy and see what is A. So we can see now here, we have A. We are basically trying to show what is frame.state is equals to Ohio. So this is a state, right? So we want to try to say, where is Ohio is true. So where is Ohio will return as true. Can you see true, true? But here it's false. But now I want to assign this guy into a new column. So here I said, you can see here I have 1, 2, 3, 4, 5, 6, right? I'm assigning it to a column instant. But in our data frame, we don't have a column called instant, right? So assigning a column, a new this guy, assigning a new value to this will create a new column called instant. So if we look at this, so we can see we have a new column. So this, what is telling us is that if you try to assign values to a column that does not exist, Pandas will think, oh, this column does not exist, then I can create a new column for you. So Pandas now create a new column for you, and now it's put at the end by default, right? So now the new column cannot be created with, so you can see here, basically previously we said that we can access a column. So here we say we can have frame, that for example, state, right? To, Falal yana gyara yana Falal ya ake ce wannan abu ne?
American City ne wani state ne
Na san American City. Ohio kace ko?
Ohio ba?
Falalu to Ohio. To, mu ai Kaduna state muka zani da Kano da Jigawa. Okay, cool. Right, thank you for, yeah. So you can see here, we can use this state frame 2.distance to give us, to select a column in our data set, right? But we can also use this format, right? To select it, state. We discussed this, we can use this, select the column here. But when you want to select 2 columns, we can use iLock, right? And we can specify, okay, select all the rows, but maybe 1 to 2. What I did here. Okay. So if we want to select, we use iLock, right? But you need to specify, for example, the rows. What can we say now if we want to specify all the rows? You need to specify that all the rows you need, but we can specify the column at this way, just the way I showed previously. But the point I want to try here to say here is that we cannot actually create a new column with this format, with this format here. Yeah, with this format here in this way. So for example, we cannot use from 2.astan. We said we assign A here. We cannot this format. Oh, it's working. Right. So what they are trying to tell us previously was that basically we cannot use this format to assign a new value. Oh, I mean, let me see something. Sham, like this. Yeah, you see, it gives me error, right? It cannot create this in this way. So you cannot use this approach to create unless I use this. So I can say sham. So this will create a new column. Can you see that? Sham. But you can not use that approach to create a new column. So that's what the point I wanted to say. So yeah, so that is another column is to use nested dictionary of dictionary. So one thing we should also know that they discuss about what is called nested dictionary of dictionary. So here I can see I have a dictionary, and inside the dictionary I have Nevada, Ohio, 1, 2. Can you see that? But inside this is also another dictionary. So you can see this is the value, this is another value. You can see dictionary inside. So what is happening here? If the nested dictionary is passed to a data frame, Pandas would interpret the outer dictionary key at the column and their inner key, the inner at the key of the row indices. So this will happen is that this outer keys, this outer will be the keys, will be the columns, and this inner keys will be your row. Can you see that? Can you see that? All right, because you have the same thing. You can see 2001. This is 2.4, right? 2001, 2.4. 2001 here in Ohio is 1.7. Can you see it's 1.7? So this is Pandas that do this automatically for you. In here, what is I don't have 2000 in Nevada. So you can see in Nevada 2000, I have none, not a number, right? So it's not available, right? So that is if you have the next set, the keys in the inner index are combined to form the index and the result. So this is not result implicit if specified. So but you can override this. You can provide the index you like, right? You can just provide the index and say, okay, this is it. . You can also transpose a data frame. So if I have my data frame, I can use t.t means to transpose it. So you can see here, for example, I have frame 3, which is basically my data frame here. You can see Nevada or Ohio. And so if I transpose it, it means the column will turn a row and the row will become that. That's also something we should know. And yeah, this is the original data. All right, so I think this is also what we discussed. If a data frame index and column have their names attribute, this will be displayed. So let's assume here we have our data frame. This is the name of the data frame. This is the name of the index. Look at the way it is. We set frame.index.name. Let me cut this guy. So if we look at this guy, we can see that frame. Oh, okay, I already set it. Anyway, so here, if you look at it from the index.name, it's here. So this is the index name here, but frame.column.name is state. This is the column name. So you can see that here, if a data frame index and column have their name attribute, this will also be displayed. So if you look at them here, the column names and the index name has been displayed. And you can use this dot values to show basically the value inside your data frame. Can you see that? We can use that. So yeah, so that's what we got. You can also actually convert to Numpy. So we can use to Numpy. I think for those that we started looking at the deep learning. So this is a method called to Numpy, because this is basically frame 3 is basically in Pandas data frame, Pandas data frame. Frame 3, this is it. But we can actually convert it to Numpy. So if you look at this one here, we have array 2.4, something like this, but we can convert it to Numpy. So using this function Numpy, this one. Yeah, so that's what we have for today. I think we can stop here, and now we can meet next week. Tomorrow is Salah, so tomorrow we don't have session. We can continue with Pandas by after Salah. Any question? Yes, Zardin, any question?
No question.
All right, so I think we are at the middle now of this book, and I'm happy like we are moving, even though slow, but we'll soon finish it and go deeper into our aim, which is deep learning. Yeah, any question?
Is it confirmed tomorrow is Salah?
To pay JJ baka so ai sallah gobe ne.
No, I'm just asking.
Okay, kun sha ruwa, ku ya garin naku yake, za a yi sallah gobe ko ba za a yi ba?
No, I'm just asking because Musa Tuesday Madam is Salah.
Tuesday?
Yes.
Sallah azumi 31 za ku yi?
A'a, ban fara da ku ba.
Au haba.
Kun riga mu farawa. 30 dama suke so a kallon da su.
To, mu dai muna so mu azumi gobe, mu yi sallah gobe.
Dokta yana son sallah gobe kuma
mutanen
suna
so amma
suna ta maganar jibi ne, Dokta.
Haka na ji ana cewa.
Sai a sa probability kenan, in ba a yi ba sai a ci gaba gobe.
Okay.
Anya Dr. Awwal a bar shi sai kaga kamar mata. Su malama Murja suna aikin sallah mata.
Okay,
haka. Sun ɗauko masu yi musu ai. Hajiya ce.
Dokta, ai ko ni ma na siyo kabewa da an fifire ta.
Yawa to kaga aka dan sa hannu.
Yeah. So one thing I was looking also is because I was thinking before the book I intend for us to use is deep learning with Python. I'm also thinking to use because I was tilted to using Python to have understand, because people who may migrate to Python is using this book Fast AI book, Deep Learning with Coders. Finally, you know the book, right? Fast AI. Yeah, so it's also a good book, and really a place to get started into deep learning. So let's see, we'll see what we can do. But yeah, any question before?
Amma wanda kai magana nan fa with PyTorch irin kamar ina ga yana da dan advantage musamman ma da kace ya dan dauko abu na wannan da muka yi a baya mun amfani da wannan library na mutum nan wanda muka yi a baya
scikit-learn
yake cewa yayi bridging da scikit-learn da waye to da ga shi ma yana da muhimmanci
wanne deep learning with Python
with PyTorch
with
PyTorch ne kace wani dai wanda kai amfani kace za a amfani da PyTorch yanzu dai ka gani dai yanda kaga ya dace amma dai wannan ka faɗi advantage ɗinsa cewa ya haɗa abubuwa ya ɗauko abubuwan scikit-learn a baya kamar kaga tunda mun yi su sannan kuma an sako
ko wannan littafin kake nufi da akwai littafin nan bari ku ga okay, let me share my am I sharing my screen now, ko? Okay, let me share my screen. Da akwai wani littafi da nake tunanin na going through da waɗanda ba su yi machine learning da su ba, su malama sana, which is let me all right, so this is the book, I think. Okay. Of this guy. Where is it? Machine learning. Okay, this is the book. Okay.